Now students, let us see how esters react with Grignard's reagent or any other organometallic compound. We are taking Grignard's reagent as an example. This is an ester, CH3, C double bond O, OET. Over here, ET stands for ethyl. We are using an abbreviation for ethyl, C2H5. Now students, in the first step, this CH3 acting as a nucleophile is going to attack on this electrophilic carbon of the ester. This is the carbonyl functional group. This pi bond will be broken down and reside on oxygen atom as a negative charge, and that negative charge is going to get attached to this positive magnesium. And you can see that a metal alkoxide complex is formed. Now students, in the second step of this reaction, it is a little different from the reactions that we have already studied. This molecule will undergo internal rearrangement. What is going to happen? That this negative charge is going to make a pi bond between carbon and oxygen, eliminating this alkoxide ion, OET. This pair will shift on oxygen as a negative charge, and that negative charge will get attached to magnesium. In this way, we will get this group as a ketone. And you can see this is not hydroxy magnesium bromide. It is ethoxy magnesium bromide now. Now students, as ketones are more reactive than esters, therefore the reaction is not going to stop at ketone. That is why we cannot use this reaction for the synthesis of ketone, because the reaction is going to proceed. A second mole or molecule of Grignard's reagent is going to attack on this ketone. This CH3 acting as a nucleophile will attack on this electrophilic carbon of the ketone, and the pi bond will be broken and attached to magnesium, giving you metal alkoxide complex. The last step is going to be the workup step, in which the oxygen is going to get this hydrogen from water. It is going to get protonated, giving you a tertiary alcohol, and this magnesium will get attached to hydroxyl, giving you hydroxy magnesium bromide. So you can see the difference in the mechanism of esters with Grignard's reagent. The second step in which the ketone is reacting is a similar step, because in the middle of this reaction it gets rearranged to give you a ketone. Then this ketone is going to react with another molecule of Grignard's reagent, giving you a tertiary alcohol. Students, the last reaction that we are going to study is the carbonation of Grignard's reagent, or we can also say nucleophilic addition of Grignard's reagent to carbon dioxide. Addition of carbon dioxide is called carbonation. Since we are reacting it with Grignard's reagent, that is why it is called carbonation of Grignard's reagent. Let us look at the reaction. This is Grignard's reagent reacting with carbon dioxide, CO2. Now you already know the partial charges. This carbon of the Grignard's reagent acting as a nucleophile is going to attack on this electrophilic carbon atom. As a result, the pi bond is going to broken down, reside on the oxygen as a negative charge, and will get attached to magnesium, giving you a complex. Now students, what is going to happen in the next step? The acidic workup, in which this negative charge of oxygen is going to abstract a proton. It will get protonated, and this magnesium will get attached to hydroxyl group. Now you can see this is CH3, C double bond O, OH. This is carboxylic acid, acetic acid, along with hydroxy magnesium bromide. Now you can see that by carbonation of Grignard's reagent, we can prepare carboxylic acids. Students, keep in mind that these are some abbreviations which are commonly used for alkyl and aryl groups. Sometimes you will see that instead of any group, Me will be written, which means methyl. If Et is written, it means ethyl. If NPR is written, it is for N-propyl. and for isopropyl it is isopr, and when pH is written it is for phenyl group. Students, I hope you have understood today's lecture. These concepts are very important. Try to apply them, practice the mechanism and solve these questions.